Hello student, welcome to all of you in the physics lecture. Myself Rajesh Lagat, physics teacher. Now we are to see the chapter number 2, mechanical properties of fluids. This is the video number 16. And next point, the surface tension on the basis of molecular theory. We are familiar with the liquid surface. We have to study here the surface tension, but on the basis of the intermolecular theory. We know that the free surface of the liquid has a tendency to contract its shape so as to minimize its surface area. We also know that the quantity of mercury fall to the floor. Then the small droplets of the mercury which are in a spherical in shape. Also the raindrops also possess this spherical in shape. From this we can conclude that the liquid tends to take the shape in which the surface area it should be minimum. We take the example, if the greasing steel needle which can be kept on the blotting paper, and this blotting paper can be placed on the surface of water, then this paper it should be absorbs the water and sink down at the bottom, but the needle will be floating on the surface of the water. What is the reason? Even though its density is greater than that of the water. What is the reason that needle can be floating on the surface of the water? Because the weight of that needle which can be balanced by the tension acting on tangentially to the concave surface of that liquid surface which is in contact. This shows that this surface of water which is in under tension, and for the same reason you can see in rainy season some insects are walking on the surface of the water in ponds. Some insects which can be walk on the surface of the water in rainy season we can see in the ponds. Okay, now we have to consider the one example to study the behavior of liquid surface on the basis of this molecular theory. This behavior of the liquid surface which can be studied by considering the forces of attraction between the molecules of the liquid. There are the two types of these molecular forces, and which is very important, cohesive force and the additive force. You have to ask in your exam for 1 marks, define cohesive force or additive force. Then the force of attraction between the molecules of same substance is called as the cohesive force. This is the cohesion force of intermolecular force of attraction between the molecules of same substance. This is the very important, same substance is called as a cohesive force. And what is meant by the additive force? Additive means what? The force of attraction between the molecules of different substances are called as a additive force. Same substance, that is the cohesive force. Different substances, that is the additive force. Then there is another definitions, the sphere of influence and the range of molecular force which are included in this surface tension on the basis of the molecular theory. What is meant by the sphere of influence? We have to consider here the three sphere of the molecules A, B and C. They are the imaginary, and so that we have to underline this word, the sphere of influence, that is an imaginary sphere with a molecule at its center and radius equal to the molecular range, which is called as the sphere of influence. They are the imaginary, and its center and radius is equal to molecular range is called as the sphere of influence. Also there is another terms, the range of molecular force, which we have to also see that range of the molecular force. The maximum distance between these molecules up to which these molecular forces are effective is called as the range of molecular force or range of molecular attraction. Maximum distance from the molecules up to which the molecular forces are effective are called as a range of molecular force. These are the important terms which are include that the surface tension on the basis of the molecular theory. which can be asked in your exam for the 1 marks. Define cohesive force, additive force, range of molecular force, sphere of influence, etc. Then we have to see here we can explain this surface tension on the basis of the molecular theory. For that purpose, we have to consider here the 3 molecules under the influence of the sphere A, B and C. See here, the sphere B, which is under the influence of the sphere A, which is well within the liquid. The sphere A, which is well within the liquid. Sphere B is just below the liquid surface, and sphere C, which is just above the liquid surface. There are the 3 sphere of influence A, B and C. The sphere A is well within the liquid, B just below the liquid surface and C just above the liquid surface. And we have to see here, this is nothing but the range of molecular force, because this is the maximum distance up to which the molecular forces are effective, so that this y dash x dash, this is nothing but the range of molecular force. Now we can see here what is the molecular theory to understand this surface tension. Consider this 3 sphere ABC well within the liquid A, just below the liquid surface B and just above the liquid surface C. Suppose this sphere of influence molecule A is completely inside the liquid, so that all the liquid molecules are symmetrically distributed around it, because this sphere A is well within the liquid and all the water molecules, they are equally distributed all over the sphere A, and so that therefore the molecules attracted equally in all direction, and so that the resultant force acting on this molecule is equal to 0. There is no force, there is no resultant force act on the sphere A. Now the molecule B is just below the liquid surface. These water molecules are greater in number, air molecules are small in number, and so that the molecules air, which is less, then the forces of attraction exerted by them on these molecules B are negligible compared to those exerted by the liquid molecules, and therefore the resultant force which can be exerted on downward direction, which is acts on the molecule B, which is inside the liquid molecule towards the downward direction. That means the sphere B, which can be the pulled downward direction. The resultant force is that sphere B is pulled into liquid to the downward direction. Then we have to consider the sphere of influence C, which is just above the liquid surface. Now here the air molecules are greater in number, liquid molecules are water molecules which are less in number. Though the liquid molecules exert a small in number, they exert the smaller force, but though the water molecules are less in number, they exerted the force which is towards the downward direction. The molecule C experiences the maximum downward force, trying to pull it into the liquid towards inside the liquid. And conclusion is that the downward pull is always greater. You have to see here, the downward pull is always greater than that of this outer pull near the liquid surface. That means the downward force is greater than that of the outward pull near the liquid surface. This is the surface tension on the basis of the molecular theory. You have to ask in your exam the question just like, describe in brief the behavior of the liquid surface on the basis of the molecular theory. Then you can draw the diagram, then you can give these terms: sphere of influence, cohesive force, additive force, range of molecular force. In this molecular forces, cohesive and additive, they are the short range forces because they are the effective over the very short distance, and beyond which they are neglected. These short range forces, because they are effective over the very short distance, beyond which they are neglected. So this is the range of molecular force, the distance up to which that forces are effective, known as the range of molecular force. These terms are including in this answer of this behavior of the liquid surface on the basis of the molecular theory. This is very important, and sometimes you have to ask the for 1 marks question, define cohesive force, additive force in the range of molecular force, sphere of influence, etc. This is the 3 marks question, and all these terms are including in this session. This point surface tension on the basis of molecular theory you can understand well. Okay, thank you.